All right, today is Tuesday, November 12th, 2019. We just came back from our 3-day weekend. We are talking about our new unit, Zeros of Polynomials. By the way, the unit guide is up online right now. The unit guide is super short. Let's go to our unit guide. Let's take a quick peek at him. If I go to Algebra 2, look how short our unit is. Whoa. Our unit has 4 lessons, a test, and we're done. There is not a single quiz. It goes straight into a test. We have exactly 5 homework assignments for this whole unit. You're doing 2 out of those 5 homework assignments tonight. Although we do have a little bit of delay because we're doing the benchmark on Thursday, which means we're doing benchmark practice tomorrow. So on Friday, we're doing 5-2, Monday, 5-3, Tuesday, 5-4, and this upcoming Wednesday, not tomorrow, but the day after, the week after that, we have our test.
Can we retake the benchmark or not?
You cannot retake the benchmark.
Oh,
But it's not, it's usually like a small part of my grade, right?
Yes, it is a homework assignment worth 100 points, just like all of our other homework assignments, and I will give you the percent that you got on the benchmark on that homework assignment. If you got 64%, I will give you 64 out of 100. Quiet raised hand, who can read our objective? Caroline. That's it, just the x-intercepts of the polynomial. Thank you, Caroline. You can, I don't know, try to pass it in. Nice throw. Okay, so let's talk about some vocab. Functions. In terms of x-intercepts, I need to define other synonyms in different forms. So functions have what? Quiet raised hand. Read the posters. Functions have what?
I can't see it, but there's a save. Oh, wait, I'll do it.
Functions have what? Quiet raised hand. Chewy.
Zeros.
Functions have zeros. Write it down. You will need to have this memorized. At least these first 2. Graphs have what? Quiet raised hand. Colby. X-intercepts. Equations have what, Oscar? Solutions. And finally, Brian, what do expressions have? They have roots. Indeed they do. Thank you, guys. All 4 of you got XP. Thank you, Jaden, for logging it. And I gave you an example of each of them beneath. Oh, it's Aurelia. Thank you, Aurelia, for getting the XP.
Hey!
It's not.
Okay.
Again, a function, I know it's a function because it has some f of x. That's how I know it's a function. I know it's a graph because it's on the coordinate plane. I mean, if you don't know what a graph looks like, I'm very worried for your education. Equations, the key word here being equate. Equations. I'll do that in a sec, yes. Equations have an equal sign. That's how you know you have an equation. And then finally, expressions, you don't have any f of x. You don't have any equal sign. You don't have anything except for just those terms. That's why it's an expression. Again, I said this already, but these left 2 terms you have to have down for today's lesson. Because today's lesson is talking about zeros. There's zeros. Our objective is finding x-intercepts. There's x-intercepts. Know these first 2 terms very well. Let's do a random event.
Ooh, I was just about to say something.
You won't.
Let's go to the right class as well. Our random event for today is, drum roll.
2 for Monday?
No.
Yeah, come on.
Game Master. Oh, you guys got so lucky.
Ooh, Aurelio.
It's like Aurelio spoke to the game warden. He's like, "Yo, can I get Game Master's games today?" We have no homework. I mean, the homework you have, but you don't do it in class. Your homework is postponed. Instead, we are playing games today.
Yeah. It's about time.
Can we do one for Monday?
No, Monday we didn't have class. If it was a sub, then I would change my mind. You guys already got games. All right. All right. So here is your general strategy. First, if I have a polynomial, what is the word that breaks up to the polynomial to make it look like this form? It starts with an F. Who knows this word? How do I break up the polynomial to turn it from something that looks like this into something that looks like it's multiplied, multiplied, and multiplied? Jay Burns.
Is it factor?
It is indeed factor. The first step should always be to factor. And I will put a little asterisk next to this to let you know sometimes it will already be factored for you. For example, take a look at example 1. This one is already factored for you. You get to skip step 1. Example 3, you need to actually do the factoring. All right. Next, you're going to set the function equal to what in order to get a solution? You're going to set the function equal to what to find the x-intercepts? Quiet, raise hand. Aurelio, shout it out.
Is it 0?
It is indeed 0. Thank you, Aurelio. Give yourself 50 XP. If I set the function equal to 0, the y value equal to 0, and I'll put this as a note out here, we're really setting the y value equal to 0, which is the definition of how to find the x-intercept. This f of x, I can really think of that as a y. This y value we set to 0. And then finally, we will use the zero product property to, and then I'm just going to give you this one, solve. Colby,
Isn't this
you got this.
stuff with the like plus or minus numbers, the graphs?
Maybe it's hard to know what you're talking about exactly. You might be thinking of,
Come on.
is it quadratic formula? Thinking of that, or it's very similar to quadratic formula. Yes, it's the same kind of steps where you need to set it equal to 0 and solve. All right, Jaden, don't be.
Sam, were you talking? Cool. That's it.
No, don't take away HP. I'm in charge of that. Let me talk about the zero product property really quickly here. If A times B is equal to 0, what do you know about A or and B? Tell me something that you know. If A times B is equal to 0, do you know possibly what A could be or possibly what B could be? Larea? Say again? One of them is 0. There it is. That's all zero product property is saying. Specifically, if A is 0, A could be 0 or B could be 0. Set them both to 0 and you can find all the possible answers. We assume in mathematics that we can do any solution. All the solutions would be this thing is 0 and this thing is 0, although technically speaking at least one of them needs to be 0. Set them both to 0, you'll find all of the answers. So, look at the similarity between the forms. A times B is equal to 0. I have an A and a B multiplied together to get 0. So what am I going to set to 0 using the zero product property over here on the right-hand side? Who's got this? I set A equal to 0, so I'm going to set what equal to 0 over here on the right-hand side? Anna.
2x plus 6, that 6 equals 0.
Write it down. 2x plus 6 needs to be set equal to 0. What else do we need to set equal to 0? Thank you, Larry. What else do we need to set equal to 0? Only one person knows. Colby.
X minus 3 equals 0.
There it is. X minus 3 could also be 0. We need to account for all possibilities here. From here, you would solve to figure out what your x-intercepts or your solutions are. So here I'm going to subtract 6 on both sides. So I'm going to get 2x is equal to negative 6. Finally, dividing both sides by 2 to get x is equal to negative 3. So we know that if I plug x equal to negative 3 into this left-hand factor, I will get 0, meaning that x equals to the negative 3 is an x-intercept. And really easily over here on the right-hand side, add 3 to both sides, and x is equal to positive 3. Again, you're setting each of these linear factors to 0. If you have 3 linear factors, set 3 things to 0. We'll see an example of that in example 1. Here we go. I'll do a fist of 5 after I do example 1 because I want to make sure we know at least one example. So, I have this already factored for you. You come back up here to step 1, factor, check. We've done step 1. We are on to step number 2. Set this thing equal to 0. This p of x, garbage now. That's just 0.
Whoa.
Wow.
That's some strong language there, Mr. Sindel. That is 0, which means I can now set all 3 of these things equal to 0. Here I go, and I'm going to have 3 people solve them. Nice, easy XP. The first thing that I set equal to 0, x minus 3 is equal to 0. The second thing I set equal to 0 is what, Anna?
2x plus 7.
2x plus 7 is equal to 0. And finally, what else do I set equal to 0? Nice, easy XP. What is the third and final thing that I set equal to 0? Yes, Caroline. X plus 1 is equal to 0. Give yourself some room because the 2x plus 7 is going to take at least 2 steps to complete. X minus 3 and x plus 1 just take 1 step. All right, so Those are the three things that I set equal to 0 because those were the three linear factors. I use the word linear because the highest degree is 1. You don't need to know that. But they're all the factors. I set each factor to 0. From there, I'm going to solve. Quiet raised hand. What is our first x-intercept? X is equal to what, Sam? X is equal to 3. And I'm going to come down here to my graph, and at x equals 3, this x-intercept, I'm going to make a point at 3.
So just swap in the sign.
For that one, yeah, you just swap the sign. For this one, it's a little bit harder. It's not -7 because I have to do some advanced math.
It's the same thing for x plus 4. It'll be x equals -4.
Yes, if I had x plus 4, it would be x equals to -4. You just have to switch it. That is a good shortcut.
Oh, that's okay. I thought that was a 4. That's a 1.
Yeah, my handwriting could improve.
That's fine.
2x plus 7. Quiet raised hand. What is the x-intercept? Tell me a few steps to get there. Anna, go for it.
So you subtract 7 from both sides,
Perfect.
and then you divide by 2.
And that is the fraction -7/2. Do you know what the decimal approximation of, or the decimal exact answer of -7/2 is? Anyone else want to help her out? -7 divided by 2 is what decimal? You can call in anyone that you would like, Anna.
Colby.
-3.5.
-3.5. You should know how to convert these back and forth. I know that 6 would be 3, so a little bit bigger than 6 is 7, so 3.5. And then I graph -3.5, which is going to be right there. That is another x-intercept. And then finally, Jaden,
Yes.
our final x-intercept is what? X is equal to
-1.
-1. Graph it. X is equal to -1. So we don't know where the curve of the function goes. Not yet. On Friday, we'll talk about that a little bit more. But we know at least that it crosses, or at least touches, the x-intercept. It might go through here. It might touch at this one point. It might go through here. We don't know, but somehow it touches the x-axis at -3.5, -1, and 3. Again, factor it, set it equal to 0. The answers, those are your x-intercepts. I need you guys now to give me a fist of 5, every single person. How well do you understand this general process? I see a 5, a 4, a 4, a 5, a 3, a 4, a 3, a 5, a 4, a 4. Sam, you're at a 4. All right. Let's try a harder example. And then example 3 is the hardest of all the possible examples I can give. Example number 2. We know it's actually giving you the problem in reverse now. It says, hey, I found the x-intercepts, or I found the zeros. You can write about this x-intercepts if you don't like the word zeros. It found the x-intercepts here at x equals 0, x equals 2, and x is equal to, a fraction, 3/5. So I need to figure out what is a possible equation that could give me those zeros. Well, if one of the zeros is x is equal to 0, that means I'm just looking for an x. Can someone explain why? Why am I looking for just an x? Not x minus 2, not x plus 3, not 5x plus 3, just an x. Why do I have just an x in the factored form when I have x equal to 0? The answer is actually easier than it might seem. You know it, you just can't stop. All right,
Wait, why can't-
sore throat.
can we put 1?
No, not until after we're done with this.
Well, you want a 0 because,
Think about it this way.
yeah, that's why.
If, for example, let's just randomly choose B. I don't know if B is the right answer or not, but let's say that we chose B. If I set this equal to 0, if I change this P of x into a 0, that means x is equal to 0, x minus 2 is equal to 0, and 5x plus 3 is equal to 0. I'm going to write down what I just said. X is equal to 0, x minus 2 is equal to 0, and 5x plus 3 is equal to 0. Well, look at that. One of the answers was just x equal to 0, just like up here. X is equal to 0. That came from the very fact that we just have an x. So I know if I have x is equal to 0, what I really, another form that I can write this, by the way, is quantity x minus 0, which is the same thing as just x. I know that this should be in my answer. So I have already eliminated A and D because I know I need an x in my answer. Just from this fact that x was equal to 0, I know that I should have something of this form or this form as one of the factors. The only thing that has a factor of x in it is b and c. A and d were both missing x. From there, the only difference between b and c is this plus sign and minus sign with the 5x plus 3, 5x minus 3. So does it let me grab? No. I want to grab, no, it doesn't let me. Weird. I'm going to delete some of this stuff. Yeah, that's HP from both of you.
Heard that? Would it be C, Mr. Sindel?
It is going to be C.
I told him to phase up. I didn't say shut up.
So Aurelia was provoking Emily. I think you can take the damage.
Wow.
And then Jaden, you responded even more negatively. So you're rude. Brian will protect you. All right, so
Oh, feels good.
I want to have x equal to 2, which means I need to have a factor of x minus whatever that is right there, x minus 2. So that's why I have x minus 2 in all of these. All of them have x minus 2 as a factor. The final thing that I need to have correctly is x is equal to 3/5. And that probably comes from the thing that has a 5 and a 3 in it. So in order to figure out which is the answer, let's just randomly say, I'm going to guess B, 5x plus 3. If I set 5x plus 3 equal to 0 like I did right here, and then solve, I'm going to first subtract 3, and I get 5x is equal to negative 3. I subtracted 3 on both sides. From there, I'm going to divide both sides by 5, and I get x is equal to negative 3/5. Notice the difference. This is a negative 3/5. I'm looking for a positive 3/5. My only difference is a sign error, which means if I had this sign change, the answer should be C. The answer is indeed C. Again, if I set every single one of these linear factors equal to 0, I would get the x-intercepts 0, 2, and 3/5. Ask me questions before we move on to example 3. Now is the time. Example 3 is going to be where it really, really heats up. All right, we're on to example number 3. I need to plot all the x-intercepts of that polynomial. It is not in factored form, which means I need to factor it. So when I have 4 terms, Leo's not here, he's our resident expert, but there's a lot of you that are really, really good now at factoring polynomials that have 4 terms in them. Does anyone remember the procedure or the name of the method that we use in order to factor this thing? Quiet raise hand here.
Start with a P.
It's not Ninja Star.
Start with a Beast.
It does not start with
with
a
an S.
P. It does not start with an S. It starts with a G.
GCF.
Caroline, yeah.
Greatest common factor.
I mean, that is always our first step.
Here's a really old-
So GCF,
Oh my God.
we'll find the GCF first. That's a good first step.
Why?
That's always our first step. I always consider that step 0. And then eventually we're going to do factor by grouping. I'll write it down here on the left-hand side. Factor by grouping. Another way of thinking of that is setting up 2 sets of parentheses around your function like this and factoring out the GCF out of both of those after you do the original GCF. Actually, I'll leave those. So first, before we begin, what is the greatest common factor of each of these 4 terms? Yes, India, go for it. Raise your hand. You got 2. It is indeed 2. The greatest common factor here is 2, so India is going to factor out a 2, and I can do this for you. If I divide 4x to the power of 3 divided by 2, I get 2x to the power of 3. If I divide 10x to the power of 2 divided by 2, and I get 5x squared. Then finally just continue the pattern, dividing by 2 each time, minus 2x and minus 5. So we factored out our greatest common factor. Let's leave that out on the side, just that 2. Now I'm going to do factor by grouping. Again, if you forgot how to do that, you set up your parentheses. Parentheses around the first 2 terms, parentheses around the last 2 terms. All right, I'm going to leave this 2 out front. That 2 is going to stay there for all of our steps. That 2 will always be there. I am now asking you, what is the greatest common factor of 2x to the power of 3 and 5x to the power of 2? Who's got it? These two terms. What is the greatest common factor of those two terms? Feet off the desk, please, Jane. Anna. It is indeed x squared. So I'm going to pull out an x squared here. And Anna, do you know what's left over after I factor out an x squared?
5x, yeah, 2x squared plus 5x, 5x.
You're really, really close. So what I'm going to do is I'm going to subtract the powers. 3 minus 2 is 1. So 2x to the power of 1 or just 2x. And then x to the power of 2 and minus 2. Exactly. There's no x there anymore. So it's just the 5. We factored out x squared, and we're left with 2x plus 5. Perfect. All right, thank you. That was the first set of yellow parentheses. Now I'm on to the second set of yellow parentheses. I want to make sure that I have the same group. Is it a question, Oscar? Yeah, what is it?
I just found it greatest common factor. How is it like x squared?
All right, let's do a little bit of review off to the side, because I know that you aren't the only one that has this question. There are a few confused faces. So make a note off to the side if you need to remember how to find the greatest common factor. The greatest common factor will, 1, GCF of coefficient. The coefficients were 2 and 5. There is no greatest common factor. You can say that the greatest common factor is 1. Step number 2 is smallest exponent. Of variable, I suppose. The smallest exponent between 3 and 2 was 2. So we factored out an x to the power of 2. So again, we need to make sure that in order to do factor by grouping, this 2x plus 5 must appear over here as well. So I'm going to add my little plus sign. There must be a 2x plus 5 out here to the right-hand side. And I'm sorry, I can zoom in here so that we can all see this. I should also have a 2x plus 5 here and here in order to have factoring by grouping correct. I need to figure out what to factor out of negative 2x minus 5 to get to positive 2x plus 5. Does anyone know what I should factor out? Anna again? It is indeed negative 1. I'll do this negative 1. We have now factored out the greatest common factor of each of these two sets of parentheses. Can anyone complete factoring by grouping, leaving that 2 out front? I should have 2 sets of parentheses now. One set of parentheses and another set of parentheses. Does anyone know what goes in these 4 spots? Lorea. So far, so good? There it is, 2x plus 5. Thank you, Lorea. Again, I'm taking x squared and negative 1 for the first set of parentheses, and then whatever the group was, in this case 2x plus 5, they're both the same here. That 2x plus 5 combines right here. So I can factor one step further. You should know this one as well. X squared minus 1. I can factor that thing even further. Does anyone see what it is? Or see how to factor it? X squared minus 1. Does that look familiar? So I'll write it down for you guys. Difference of squares. Whenever you have a difference of squares, that's something of the form a squared minus b squared. When I have a difference of squares, which I do in this case because x squared is a square, 1 is a square. This is going to turn into a plus b times a minus b. And while I'm here, I'm just going to give you the formula for sum of squares because that is going to be on our homework. I just ran out of room in the notes to add it. I'll do it in a different color. Sum of squares. I'm hoping this is review, which means you can learn it really quickly again, or just have it memorized. Sum of squares is in the form a squared plus 2ab plus b squared, and that turns into a plus b quantity squared. You need to know difference of squares, sum of squares, factoring by grouping, and advanced ninja star for this lesson. We've been doing those over and over again, so I'm hoping that most people are starting to get it down now. So from here, since I know how to do difference of squares, I have that information in the top left, I can now apply that rule to x squared minus 1. The 2 is still there, it's out front. Can someone now help me factor x squared minus 1 as 2 binomials? Who's got it? Use the formula. Use the force, Luke. Use the formula, Luke. Come on, who's got this? Anna did the last 2. I have to get it to someone else. Sorry, Wonder Power team. It's going to have to go to someone else. I will cold call on someone. Let's go with Chewy.
Shit.
Chewy, you got this. Take the square root of x squared. What do you get?
1.
Square root of x squared. The square goes where you were left with. You got this, Chewy. Square root of x squared. Get rid of the square. X. So this first term is x and x. Take the square root of 1. You get 1. What are the middle signs that I should be using here, Chewy? Plus and minus. There it is. Thank you. So we have now factored x squared minus 1 into these 2 different factors, and I still am left with this 2x plus 5. That hasn't gone anywhere. I have to copy that down again. 2x plus 5. All right. That was hard. That was just step 1. Let me zoom back out here. That was step 1, to factor. Now we're doing step 2 and 3, setting equal to 0 and using the zero product property to solve. So when I come back down here, I now need to set 2 equal to 0. Well, that doesn't make sense. I can't say 2 is equal to 0 because 2 can't be equal to 0. I mean, you can try. You can say, okay, 2 equals 0. Well, it doesn't work. 2 cannot be 0, not at least in the realms of our normal mathematics. Let's try another one. 2x plus 1. Let's set that equal to 0. Oh, that's easy. What x-intercept does that give us? X is equal to what? Quiet raised hand. When I set x plus 1 equal to 0, x is equal to what? Samantha, you got this. Subtract 1 from both sides. Subtract 1 from both sides. It is indeed negative 1. X is equal to negative 1. Let's go ahead and graph that on our graph. Negative 1. There it is. Let's try the next linear factor. Let's set that equal to 0. I'm feeling like we're going to change this to blue. X minus 1 is set equal to 0. Which means my other x-intercept is what? Hold it high, India. 1. Thank you, India. Thank you, Sam. It's going to be a positive 1. From there, I also have 2x plus 5. I'm going to set that equal to 0. 2x plus 5 is set equal to 0. This is going to require 2 steps, which you still learn in your first year of Algebra 1, so I hope we still got this down. I'm going to subtract 5 from both sides, and I get 2x is equal to negative 5. Keep solving. After we subtract 5 from both sides, I finally divide both sides by 2, and I'm left with x is equal to negative 5 halves. And quiet raised hand, the decimal version of negative 5 halves is what? I need the decimal form. I know India knows it. She just did the last one, though. Colby. Negative 2.5. That 5 could use some work. There it is. Negative 2.5. So I'm going to come over here to negative 2.5. And there is our answer. We know that it has x-intercepts here, here, and here, -2.5, -1, and 1. It was a lot of work just to find those x-intercepts, but that is the type of math you're doing for the homework and the type of stuff that's going to be on the benchmark.
Why am I playing a game?
So that's all I have for you guys in terms of the lesson. Give me a fist of 5 for our objective. How well can you find x-intercepts of a polynomial? Fist of 5 for the objective. Let's go around. Chewy. 4, 4, 3, 4. Oh, sorry, 5, 4, 5, 5, 4, 3. Is that a 4 and a 3? Okay, those are pretty high scores. All right, so that concludes the lesson.